Okay, folks, now we're looking at factoring out polynomials, okay, that aren't necessarily perfect squares. They're not the difference of two squares, okay? They're just trinomials. And the first ones that we're going to start with, and I'm going to copy this again down here, you're writing it as your title, which says factoring patterns for x squared plus something x plus something, okay? They use variables in there. But what they're saying is, if there's no number in front of the x squared, right? It's not 4x squared. It's just 1x squared. And I get plus something x plus something, right? They used b and c here to represent that. Here's how I factor it. And I'm going to show you how to factor it. Okay? Now, the first thing that we have here in example 1, it's already factored. But I wanted to keep this factor to show you what happens when we multiply them, because that will help us figure out what to do to unmultiply them. Also known as factoring. Factoring. Okay? All right. And this says when c is positive. All right, well, let's look at that. Let's see what that means. Okay, you don't know what that means yet because we've just started the section. You're going, what are you talking about? Okay, well, let me finish talking. Okay? When I look at this one, I've got two binomials multiplied together. I want to look at this number and this number, plus 3 and plus 5. I'm going to put them up. No, you know what? I'm going to write them over here for the moment. I'll put a comma between them. They're going to come back into play in a minute when we're looking at factoring. All right? So I'm putting these over here for the moment. Now let's go ahead and multiply this thing out. X times x is x squared. You know what? I don't normally do that. I write below it. That's x squared. X times 5 is 5x. 3 times x is 3x. And 3 times 5 is 15. Okay? Now I've multiplied. This is nothing that you guys haven't done a zillion times. But now I need to combine like terms. So I'm going to get x squared plus 8x plus 15. So when I multiply them, that's what I get. Okay? Now, I want you to raise your hands, and I don't want to wait forever because the people online don't want to wait forever either. But let me ask you something. Let's look at the number in front of the x and then the constant back here. And I'm also looking at their signs. What do those two numbers have in common with these? I don't know if you guys can see that. I'd like a point. Oh, wait. I can do this. Okay, I don't know what that means. Okay. All right. What do these numbers have in common with those numbers? Cameron?
When you add 5 and 2, you get 8.
When you add them, you get the middle number. When you multiply them, you get the last number. When I add these two, I get the middle number. When I multiply them, I get the last number. Okay. So let's take just a moment. Let's look at this thing from the end now. X squared plus 8x plus 15. And if I wanted to factor this thing, what goes in the front, Jet, of these two binomials? X goes in the front, right? So when I multiply them, I get x squared. But now what numbers go back here? You know what we do? We take the number 15 and we write its factors. 1 times 15, that gives me 15. And 3 times 5, that gives me 15. Which pair adds up to give me the middle number? Which pair, Allie? 3 and 5. Plus 3, plus 5. Okay, that's good. Let me ask you this. What if I had this? X squared plus 16x plus 15. Let's quickly factor this one. What goes in front, Coolis? X goes in front. Take the last number and factor it. Okay, 1 and 15, 3 and 5. Which pair gives me 16, Millet? The 1 and 15. Plus 1, plus 15. Mr. C, does it matter?